name is Claire Elgar, and I will be completing the Unit 2 assignment for the case connections. So for the first case, I chose case 2. As presented in case 2, there is a 16-year-old patient that presents with a deficiency in muscle glycogen phosphorylase enzyme. As discussed in the lecture, this disease can be known as McArdle syndrome. The family has some concerns due to the recent diagnosis and would like some questions answered. So the family would like to know how muscle glycogen is normally used during exercise, if the patient will still be able to take long walks with her friends since this is an activity she mentioned she enjoys, if she'll be able to, or if she'll need to get up in the middle of the night to eat to be able to maintain her blood glucose levels, and if there's a need to worry about excess lactate production during anaerobic exercise. So muscle glycogen normally goes through glycogenolysis so that glycogen can be broken down to be used as fuel during exercise. So glycogen typically uses glycogen phosphorylase enzyme to free up glucose 1-phosphate, which then during anaerobic exercise is converted to lactate, and that'll be further discussed later to answer some of the family's questions. But the deficiency in the glycogen phosphorylase enzyme will lead to a buildup of glycogen in the muscle since it's unable to convert the glucose 1-phosphate. It is stuck in the initial step, which is the glycogen. And this can make tolerating exercise especially difficult. So walking is considered a form of aerobic activity, and during this, the skeletal muscle will be using free fatty acids for energy during this form of exercise. So taking walks with her friends should be able to be tolerated due to being able to use those free fatty acids as a form of energy. However, after a long period of time on those long walks, there might have to be some breaks taken, or they might have to cut their walk short just because after her free fatty acids have been depleted, there will be no more source of an energy because glycogen will be unable to be used. So if glycogenolysis is not going through the pathway as it should, maintaining blood glucose levels is going to be difficult. The deficiency in the glycogen phosphorylase enzyme will lead to decreased levels of the glucose 1-phosphate because it can't be converted to that, which then limits glycolysis as well. So typically in non-muscular cells, glucose 1-phosphate will be further isomerized to glucose 6-phosphate to then feed into the glycolysis pathway and support those blood glucose levels during a fasted state. But since these pathways are not functioning properly, blood glucose will be in less of a homeostasis. So there is a potential for needing to eat in the middle of the night just due to that being considered a fasted state. And there'll be limited ability to maintain that homeostasis of the blood glucose levels during that time. So as mentioned earlier, during normal glycogenolysis, in muscle cells, glucose 1-phosphate will be further converted to lactate during anaerobic exercise. However, during anaerobic exercise with a deficiency in the glycogen phosphorylase enzyme, there will actually be lower levels of lactate detected after intense exercise, they found in some studies. So there won't be a need to worry about excess lactate being produced. So that completes the first case study that I did, and we'll move on to the second case study that I followed. So the second one I chose to do was case 4. So in this, the healthy baby presents with jittery spells after breastfeeding and has been exclusively consuming breast milk since birth. Her lab results indicate hypoglycemia, which is low blood glucose levels, and it's also noted that after epinephrine is administered, there is no increase in blood glucose, but that there is an increase in blood lactate levels. A physical examination of the infant shows hepatomegaly, which is then enlargement of the liver. So we can start looking at some of the diagnosis options and see which one fits best. So this patient would not be considered for having hereditary fructose intolerance because fructose is not a component of lactose, which is what breast milk is. Fructose is a component of some formulas containing sucrose. So that really isn't an option for one of the potentials for this infant's diagnosis. So the next one is galactosemia, which is a disease caused by the block in the galactose-1 phosphate uridyl transferase enzyme, which is also shortened to be known as GALT. So this leads to the elevated levels of galactose-1 phosphate and the inability to break down galactose to glucose. Galactosemia will lead to liver failure due to the accumulation of the galactose-1 phosphate in the liver. However, it would not really explain the other symptoms that are present, so due to that, we won't really consider that an option for the infant's diagnosis. Glucose 6-phosphate dehydrogenase deficiency impacts the pentose phosphate pathway. So this deficiency will specifically affect the oxidative portion of this pathway, where glucose 6-phosphate dehydrogenase enzyme converts glucose 6-phosphate to 6-phosphogluconate. Therefore, the inability to do this conversion will result in the accumulation of the glucose 6-phosphate. This deficiency will more so affect red blood cells and can lead to hemolysis or jaundice due to the decrease in the NADPH production, because that is a primary product of the pentose phosphate pathway and it's not going through its completion. So we don't really consider that the best option for a diagnosis either. So the last diagnosis to look at is going to be the glycogen storage disease, or the inability to use glycogen. So one example of a glycogen storage disease that we discussed during the lectures was von Gurk's disease, which lacks the enzyme glucose 6-phosphatase. So this typically affects both gluconeogenesis and glycolysis. If glycogen is unable to be stored, this would make sense as to why the infant would have changes in blood glucose levels after feeding, but during a fasting state there would be no glycogen stores to be used to regulate the blood glucose levels during this time, so therefore that would explain why we wouldn't see a change, or we wouldn't see good levels of blood glucose during a fasting period. This would also explain why the epinephrine is not causing an increase in the blood glucose levels. So gluconeogenesis is usually stimulated by epinephrine, and it is able to produce glucose to regulate the blood glucose levels. But with a glycogen storage disease, the pyruvate is actually unable to be converted to produce the glucose due to the deficiency in the glucose 6-phosphatase enzyme. So some typical clinical symptoms of glycogen storage diseases also include an enlarged liver or hepatomegaly, which was found with the infant's physical examination, and low blood glucose levels, which is known as hypoglycemia. So based on the total of information found that comes along with a glycogen storage disease, we can best use our information to diagnose the patient with this disease. So this finishes up Case 4 and concludes the Unit 2 Case Connections activity. Thank you for watching.